resolution of two vectors. Resolution of two vectors. First and foremost, what is a vector? What is a vector? A vector is any physical quantity that have magnitude and direction. A vector is any physical quantity that has magnitude and direction. So whenever a quantity is having magnitude, which as well can be referred to as size, and it has also direction, it's said to be a vector. And we usually represent direction with an arrow in physics. So we are going to see how two vectors can be resolved. Now, in resolving two vectors, we shall consider vectors along the vertical axis. And of course, we know along the vertical axis is known as y. Then along the horizontal axis is known as x. So let's look at the demonstration below. Of course, we know that this is negative y axis, and this is negative what? X axis. So this is minus x, and this is what?
Plus y. Sorry, plus x.
This is plus
y minus y.
So assuming we are considering the resolution of vector along this direction. Now the two vectors we shall consider will be along the what? Positive y axis and along the what? Positive x axis. So in that case we don't use this negative axis of x and y. Now in this regard, assuming we have an angle that is inclined with respect to this resultant and the horizontal known as theta, and let's say the resultant is r, it is telling you that the magnitude of this resultant is from here to here. That is the size. And then the vertical component of this resultant, which is along the y-axis, is known as r subscript y, which is equals to 0. So the vertical component is r subscript y. R subscript y equals to r sin theta. So we usually represent the vertical component with respect to sine, then horizontal with respect to what? Cos. Now the horizontal component is r subscript x, which is equals to r cos theta. Now what is the effect of components in vector, of any resultant vector? Now when we are talking about resolution of two vectors, you definitely consider the vertical component, which is along the y-axis, and the horizontal component, which is along the x-axis. Now what is the effectiveness of vertical component or horizontal component? The effect of it is it gives us the effectiveness, or it shows us the effective value of the component along the y-axis and along the what? X-axis with the direction. If you don't know the horizontal or the vertical component of any resultant vector, then you cannot fully describe the resolution of that vector, or you cannot describe fully the resultant of such vectors, because the vertical components of any resultant and the horizontal component of any resultant vector gives us a complete description of such resultant vector. It gives us a better understanding of such resultant vector. We can actually tell the direction of that resultant vector and what? The magnitude of that resultant vector to our understanding, and we can deduce some information for scientific innovations, and that is why it's very important. So in this case, if assuming we trace a line with a dotted line, by the time it actually meets this resultant, you bring it down, it gives us what? A rectangle, right? Or a square, whether rectangle or a square. You know that opposite sides of a rectangle or square is the same. True or false? So if it is true, then it means that this can also be what? Rx. Because this is opposite this, right? And this can also be what? Ry. And of course, you know what Ry is talking about. Ry is what? This. And R is what? This. So for example, if you are asked to calculate, let's say for example, let's look at an example here to understand fully what I'm talking about here. Assuming you have a resultant in this direction, let's say the resultant is 5 Newton. The resultant vector is what? 5 Newton. And here we have y and we have x. And you are asked to calculate the resultant component along the what? Vertical axis. And the resultant component along the what? X what? Axis. And assuming the angle theta is given as what? 60 what? Degree. All what you need to do is just to apply this formula. The vertical component is just ry equals what? R sine theta, which is r is what here? 5, right? We have 5 times sine 60. Theta is what? 60. So we have 5 times sine 60 is what? Get what?
$0.5. 0.5? Wait, who has math textbook close with it? Wait. So I start from the 5 times sine 60.
Okay. Some please calculate it. Oh, wow.
Pause.
5 times 0.8660 is 4.3 Newton. That is the what? Vertical component along y-axis, which is ry. So let's calculate the horizontal component along x-axis. So we have r substitute what? X, which is what? R cos theta. So r is what? 5. So we have 5 times cos theta is what? 60. So we have 5 times cos 60 is what?
0.5.
Which is simple as half, right?
Yes.
So 5 times 1 is what? 5 over 2. That is what? 2.5 Newton. So the horizontal component along the x-axis is what? 2.5 Newton, which actually determines the effective value along the what? X-axis, or is the effective value along the x horizontal axis. This is the result of what? 2 vectors. Now we're looking at resolution of more than what? 2 vectors. Now we're looking at resolution of more than 2 vectors. In our previous video, we're able to see how 2 vectors can be resolved to either vertical component and horizontal component. Or in this case, today's video, we're looking at resolution of more than 2 vectors. That is a situation where we have more than 2 forces acting in different directions. So the aim of this lesson is to see how we can resolve those forces to either vertical component or horizontal component. That is what we are going to do in this video. So let us look at a sketch that will help us to understand the concept of this topic. Assuming this is 0. You know, in mathematics, from 0 upward is what? Plus y. 0 downward is what? Minus y. 0 to the right is what? Plus x. To the left is what? Minus x. Now, in a situation where you have forces acting in different directions, let's assume that we have force 1 here, and we have force 2 here, and then possibly we have another force here. Let's say force 3. Force 3 acting in this direction. And we are asked to resolve F1, F3, F2 to either what? Vertical or horizontal direction. This is what we are going to do. So in doing that, you have to consider the horizontal direction. You know that horizontal direction will have 2 sides, positive and what? Negative. Vertical, positive and what? Negative. So in resolving to horizontal direction, this is the dividing line. The vertical line is what? Dividing line. This is the dividing line that demarcates the positive x-axis and what? Negative x-axis. So in trying to resolve from here, this way is positive x-axis. So this way is negative x-axis. And in resolving, you must consider angle also. If this is f1, this will be what? Theta 1. Since this is f3, this will give you theta 3. Since this is f2, this should be theta 2. And assuming we have F4 here, this automatically is angle 90, right? So that will tell you that the angle with respect to this is what? Angle what? 90. Because the angle must be sustained with respect to what? Horizontal. So if this is 90, it means that this force is with respect to what? Angle 90. And this is with respect to what? This. Now, but in a situation whereby this angle theta 2 is not given, if this theta 2 is not given, you already know that from here to here is what? Angle 90, right? Or here to here is angle 90. Let me put it this way. Angle 90. So if this F2 is not given, it means that for you to determine the angle from here to here, that will give you theta 2 is going to be what? 90 minus what? 90 minus what? 90 minus theta is equals to 90 minus.
So you have to name the other one.
This one, right?
No, the other one. So that by the time you subtract that one, it will give you that other one. Like let's.
Theta 2. Let me indicate another one here. I'm trying to figure out something. Let's say this is F5 now. And we have angle theta 5 here. That's what I was trying to figure out. From here to here, it's 90, right? So for you to determine the angle of this line, it's going to be what? 90 minus what? Theta 5. That's what I'm trying to do. Now, whatever I have is this angle here.
Yes.
So, in a nutshell, what I'm trying to do is, in resolving forces to horizontal and vertical component, you consider the direction. For example, now, if you are resolving this one now to horizontal, that is x component. You have F1, that's plus, right? You know this way is plus, right? This side, this way is plus x. So you have F1 cos what? Theta 1 equals to whatsoever you have, you write it here. Now, here, is it not negative? This way, negative x. This side is negative x, right? Are we together?
Yes, sir.
Negative x, so you have minus F3 cos what? Cos theta 3. Now, coming here now, it's still negative as is. Negative. So you have what? Minus F2 cos theta 2. Now coming here, you have F4 is positive, right? This way is positive. This dividing line is positive. It's neither negative, it's not negative. Dividing line is always positive. So you have F4 cos what? Cos 90 minus theta 5. 90 minus theta 5 for this angle. 90 from here to here is 90 minus theta 5. So I have is the angle. Now F5 now is what is left here. So for us to get this, it's still 90 minus theta 5. Still the same thing. 90 minus theta 5. That's for horizontal axis. So that's that. So in resolving for vertical, from this part upward is what? Positive. This way is what? Negative. So this will be F1 sine theta 1. Coming here now is positive now, but I'm considering vertical. So it's going to be F3 sine theta 3. Coming here is negative. Negative y-axis. So you have minus F2 sine theta 2. Coming here is negative also. It's positive because this is the Okay, it's still negative because we are considering vertical. It's negative. So we have minus f4 sine 90 minus theta 5. This and this will have the same angle. So here we have minus f5 sine 90 minus theta 5 also. So that's the concept behind all these things. So once you are able to do that, you sum up whatever you have. You sum up whatever you have. You have summation of f of y. Whatever you have is your answer. Then you come here.
Why is it somebody must have minus?
So yes, this is vertical y component, right? This way is positive. This way is what? Negative. That's why some have positive, some negative. Look at, let me start again. Don't video. Please start.